Alright, this is problem HRW94P039, and it has a building, and it says you throw a ball leftward horizontally off a building, and it falls in a certain amount of time they give you, and it falls a distance, or not falls a distance, it goes a distance d from where you threw it, and when it lands, it has a velocity where it lands at an angle of 46 degrees to the horizontal. And they want several things, but the first thing they want is the height of the building. So this is a very difficult problem. We actually have to work backwards. So the only thing I really know anything about is how it lands. So let's start with there. I've got a velocity that lands at an angle. Call that v. But it lands at an angle because we've got some x and some y components here. So I've got a y component that points down, Vy, and I've probably got an x component that points to the left, Vx. Okay, and I know this angle right here. I know that angle is theta. So I don't know this, I don't know this. It looks like I don't know anything, but I actually do know one thing. I know Vx. I know Vx because I know how far it went, and I know how much time that took. And a velocity that is constant I can find with distance over time. Now I know the velocity in the x direction is constant because from the moment it was thrown to the moment it lands, nothing is acting on this ball in the x direction. Gravity is pulling down on it in the y direction, but nothing going on in x. So I have a d and I have a time. That gives me a x velocity of 16.564 meters per second. Okay, and by the way, just to make things a little bit easier for myself, I'm making left positive since things only move in the left direction in this thing. Okay, so now I know this leg right here, and I have this angle. So if I want to find Vy, which I do because I want to know the height, and height is a y thing, so I need to know stuff about y direction. Well, I've got y is opposite, I've got an adjacent. I know that the tangent of that angle has to be opposite over adjacent. So if I multiply both sides by Vx, I know that Vy is Vx tangent of theta. If I put my numbers in, and I'm not going to actually rewrite it because I'm running out of room, but if I put my numbers in, my Vy ends up being 17.153. Oops, come on. But I have something to add to that. My Vy is down, so I should just slip a negative right in front of that. Okay? So that's the velocity in the y direction when it hits the ground. So if I put together my all of my stuff that I know in the y direction, let's go back to black here. All the stuff I know in the y direction, well, I know it's going to end up on the ground. Oh, sorry. It starts at a height h, so I'm going to leave that. I'm going to put that as like an h. I know it ends up on the ground, so its y after the time t should be 0. I don't know what its initial velocity is when it leaves the roof, but I do now know that Vy is negative 17.153 meters per second. I also know acceleration. Acceleration is negative 9.8 meters per second squared, and I know the time. The time it took to fall, they gave me 1.63 seconds. Okay, so if I want to know h, let's see, I know time, so I could use the first equation, but I don't know initial velocity. In fact, to use any of the three equations, I really need initial velocity. So let's find that first, and then maybe I can solve for h. Okay, so I want v naught y. So to use v naught y, I can use this equation. and I'm going to add y's to everything just to be really clear what we're talking about. I can use this one because I have t, I have a, I have vy. All I don't have is this. So if I solve for that, let's see, move at to the other side, I get initial velocity in the y direction is velocity when it hits the ground in the y direction minus at. So that, put in the numbers, I have negative 17.153 minus a negative 9.8 times 1.63. So what I have here is negative a negative. What I really have is like a positive. Okay, if I do all that, put that in a calculator, I get that the initial velocity in the y direction was negative 1.179 meters per second. Now that's interesting. That means it was thrown slightly down, so my picture is off. It really should have pointed kind of like this, like down-ish, okay? And that's going to come in handy for part C when we do part C. Okay, so now I know that. I can go add it to the stuff I know about y direction. Basically, now I know everything except for h. So I can use any equation I want to solve for h. So I'm going to use the one that's most closely solved for h already. And that's the big one. Y equals y naught plus initial velocity in the y direction times time plus 1/2 at squared. Well, put in what zeros you can. See, that's 0. That's h plus negative 1.179. I'm going to leave the units off just to save a little time. 1.63. Let's see. I know a is going to be negative, so I'm just going to go ahead and put negative. I also know a is 9.8, so I'm going to go ahead and do the 1/2. This is something that you should remember. 1/2 of gravity is 4.9, because you put gravity there a lot, so it's just a good thing to jump right to it. 1.63 squared. Okay, well, I want to get h alone. I could just subtract h to this side. In fact, I think that's what I'm going to do. Just subtract h to that side, and I get a bunch of numbers. Over here, I've got all of this, all of that. I end up with negative 14 point... Let me check that on the calculator. Okay, I checked it. Negative 14.94 meters, and then just multiply by -1 to get the answer. So I got an answer. Woo! Part B asks for the magnitude of the initial velocity. That's a lot easier because I already have both of the components. Here's the where is it? Here's the y component, and the x component was this up here because Vx doesn't change as it's flying, so that's also initial x velocity. So my total initial velocity ends up being the square root of those two things squared. And if you throw both of those in the calculator, we get 16.6, oops, come on, meters per second. Okay, so that's part B. And then part C asks for the angle. You know what? I don't want to turn the page. I'm going to try and squeeze it in here with another color. How about this slate color again? Or I guess I haven't used it yet. Alright, so the angle is the inverse tangent, squeeze it, of the y component over the x component. If you throw that in a calculator, we're going to get 4.07 degrees. Now that's 4.07 degrees with the x-axis, and it just asks for the magnitude, so that is the answer for part B. Part C. And then part D, if I'm thinking about this right, yeah, it asks if that's above or below the x-axis. That goes back to, well, my y component was negative. So really, I was going kind of like this. So it's below the x-axis. And that's it. Very difficult, but now it's over. Yay!